Hi everyone, welcome to our video on factoring where we're going to look at all of the different cases of factoring where we have the 4 terms, the 3 terms, and the 2 terms. Okay, so to completely factor, our first step is always to find the greatest common factor of all terms. Okay, so on this first one, we have 4 terms involved in it. So looking at all 4, notice there's no numerical part that's the same for all 4. And then, well, this has x, 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 but that last one doesn't. So that means x is also not a greatest common factor. So what we would say with this one, since there's no numerical common factor and no variable common factor, we would just say the greatest common factor is 1. 1 will always be in common. But we don't really have to do anything with it. So we just kind of move on to the next step. So the next step, whenever you have 4 terms, is to group the first 2 terms and to group the second 2 terms. Grouping these first 2 terms, now I will factor whatever I can out of it. So notice that there's an x in common in both of these terms. So I can take that out, and then I'd be left with an x plus y in my parentheses. And remember to check as you go. You can do a quick distribute, a quick multiply to verify that this is the same as above. And then in our second 2 terms, it looks like I have a 5 that's in common. So I have a plus 5, so I want to include a sign. So plus 5, and then an x plus y would be left over in the parentheses. And again, quick check, the 5 distributes and it would match what's directly above. Okay, and then now that we have it written like this, I'm going to use a green color here to box. These are 2 big separate terms by this plus sign. So here's one term plus here's our second term. Well, in these 2 terms, this x plus y is common in both. So what I'm boxing is common in both, which means I can take that out. Just like I did the x in the first grouping and the 5 in the second grouping. So I could take this out to the front. And then while I'm left with this x, so parentheses, another x, plus 5. And there we go. And now it's completely factored. So we'll box that up. That's our answer. You can always check your answer with factoring. So if I were to check a factoring problem, I just FOIL it out, just multiply, and well, x times x is x squared, x times 5 is 5x, y times x is xy, and then 5 times y is 5y. And notice this matches what we have above. The order's a little different, but you could always rearrange with addition. Okay, so there we go. So that's how we can do it with 4 terms. Okay, so if you want to try this one on your own, go ahead, pause it. You can fast forward. But let's break it down. So just like the last one, I look at all 4 terms. It doesn't look like anything's in common in all 4. So I'm going to say the greatest common factor is 1. Just to remind me that that is the most important first step. And then now that it's done, I just move on. All right, so this grouped in this grouping, I see that in our first grouping, it looks like there's a y in common. So we'll take that y out, and we're left with x minus 5. And then in our second one, it looks like there's a 2 in common. Now, I left a space. We need to put a sign there, so it's up to us to choose whether to do a positive or a negative. Well, in this case, I want to use the negative that's with it. Because when I take that out, well, this plus sign would need to change to a minus. Okay, and so the 2 gets taken out of each of these numbers here, which is like division. So 2 divided by 2 is the 1 there. 10 divided by 2 is the 5. And again, do a very quick check with multiplying. The negative 2, if it were to distribute back in, negative 2x would be there. Negative 2 and negative 5 would be positive 10. Okay, so it matches. And then now it's just like the last one where this binomial, notice they have to be identical too. So that's the other reason we wanted to take out the negative 2 instead of a positive 2. If that was a plus and this was a minus, then we wouldn't be able to factor. So these have to be identical to factor. So these are called binomials because they have 2 terms in them. So binomials must be identical to factor. Okay, so that means their signs have to match, the powers have to match, the numbers have to match, everything has to be the same. Okay, anyway, and they are, so that's good. So that means we could just take it out, x minus 5 to the front, and then it looks like we have y minus 2 left over. So this y minus that 2 is left over in the second set of parentheses. And then that's that. Okay, and again, quick check. I'm just going to write the word check and say, yep, it will work if we were to multiply, just to save a little time. Okay, so, but just remember to do that, though, especially on tests and quizzes and all important work. All right, so moving on. So these were the four terms with 4. So they come about. The most frequent factoring is usually 3 terms, which is our next bunch. Okay, so if you want to take a pause for this 4, I'm going to keep it going. I'm going to keep this all in one kind of long video, so of the factoring. Okay, so there's different ways, though, to do these. So these are trinomials because they have 3 terms. So these are examples of trinomials. Okay, because 3 terms, like tricycle has 3 wheels, trinomial, 3 terms. Okay, and same deal, binomials, like bicycle, 2 wheels, binomial, 2 terms. Anyway, so what we know is going to happen, so trinomials will factor, or yeah, let's say it like that, will factor into 2 binomials. So they'll look kind of like our answers from above that are boxed right above. Okay, so the way that we do this, so there's different methods. I'm going to use this method here where we're going to take, so there's a 1 in front. So this 1, I'm going to take it and multiply by the negative 44. And we get negative 44. And then now I'm just going to write the factors of 44. So that just means you just want to find 2 numbers that multiply and make 44. Well, 1 and the number itself will always work. 44 is even, so 2 would go into it. So 2 and 22, that works as well. And then 3 does not go into 44, but 4 does. 4 and then 11 goes into it. So 4 times 11. So all these pairs multiply and make 44. And then that's it. So 5 doesn't go, 6 doesn't go, 7, 8, 9, 10 don't go. And then now we have 11. And so we've got all of them. Okay, and then one of these pairs should match where we're going, where we need these 2 pairs to add up to give us negative 7. Okay, so we choose the signs to make that happen. Well, these 2 pairs can make, or this pair can make it happen. If I were to choose a negative 11 and a positive 4, these add up to make negative 7. Okay, and then now that it is a match, what we can do, one last thing we have to check is make sure that this does multiply and give you the negative 44. So one quick check, does that multiply and give us back that answer? Yes. So we need this sum. We need these need to add. So I'm going to say sum is middle coefficient, so that negative 7. And then we just have to double check to make sure that they multiply and do match the negative 44. Okay, and that checks too. So we have both of them. And then now let's break it down. So one way to do this is to rewrite this middle term. So I'm going to leave it as y squared. And then rewriting this as plus 4y minus 11y minus 44. So I just rewrote the middle term using those 2 coefficients instead, the 4 and the negative 11. Again, notice that these add up to make negative 7. Okay, and then now that we've rewritten it like this, it's 4 terms, which means it's just like from above. So that means I want to take these 2, and I want to take these 2 and group them. And so I would take the y out of the first 2, which is leaving us with y plus 4. And then out of the second 2, I'd want to take a negative 11 out. 11's in common, which gives me y plus 4. And again, double check, quick multiplication, it does work out. And then now it's just like the last 2 problems where this y plus 4 is common in both terms. So that means we could take it out to the front. And then we're left with that y minus 11 in the second. Just like that. There it all is. Okay, and again, just like with these problems, you can check with multiplying. If I FOIL this out, I have y times y is y squared. And then y times negative 11 is a negative 11y. Positive 4 times y is positive 4y. positive 4 times negative 11 is negative 44. These middle terms add up to give us negative 7y. So it is a check. It does work. Okay, so remember, always check with your factoring. Okay, anyway, so that's how that one breaks down. Let me go ahead and kind of block that off a little bit since it ran into my number 4. Okay, and notice again, this was a trinomial, and our answer is 2 binomials. So once it factors, it's 2 binomials. Okay, so let's take a look at this one. So in this scenario, I have x squared minus 29x plus 100. And so I'm going to do it the same way where I know this 1 in front of that x squared multiplies the 100. So we take our first coefficient times it by the last coefficient. And then once we do that, we get our factors. And you can, if you know it right away, you can jump to it. You don't need to list them all. But I'm going to just do it for this problem. So 1 in 100 makes 100. 2 times 50 makes 100. 3 does not go into 100, but 4 does. 4 goes into it 25 times. 5 goes into it 20 times. 6 doesn't go into 100. 7 doesn't. 8 does not. 9 does not. 10 does. And then that's it. That's all of them. So once you get a value on the right side, I don't need to continue counting. So 11 doesn't go into it because I already have 10 as the smallest number over here. So that means anything bigger than 10 is already counted for in this right kind of column here. Okay, anyway, so now I just want to look at it and I want to see which one of these gives me negative 29. Well, it looks like if I were to choose these two to make them both negative, that would add up to give me negative 29. And then again, notice that these multiply and give me positive 100. Negative 4 times negative 25 is positive 100. So that means both scenarios are checked, and now we can continue with the problem. Okay, so there's also, all right, so let's break this down. We're going to do this in one step. Let's notice one thing from the previous problem. So notice our factors here that were circled, the 4 and the negative 11. Were right there and right there. So this is a special case. So if this coefficient is 1 in the front, we can instantly just take that variable, whatever it is, x. So just like we did on this one, it was y. So I'm taking the x. I'm going to put the minus 4 after it. And then another parentheses, another x, and then the minus 25 after it. And then that is going to be our answer. So we can save these middle steps. It takes less time, and we can do that when it's a coefficient of 1 on our front one. Okay, so a little messy, sorry. So we can rewrite our factors. We can do this method when the coefficient on the x squared is 1, or the y squared, whatever variable they use. Okay, so we can instantly just rewrite our answer out without doing these middle steps. Okay, so that's only if the coefficient is 1. And then again, I would say double check. It does work. Just quick check. X times x is x squared. Negative 25x. Negative 4x. Positive 100. And so those two combine to give us negative 29x. So it's good. Okay, so anyway, so use that method whenever it's a coefficient of 1. All right, so let's see these other ones. Oh, one thing I have been forgetting, I've just been jumping into it. Sorry about this. Let's backtrack a little bit on these problems. I did not mention the greatest common factor. I looked at these and immediately saw the greatest common factor was 1, but I forgot to mention it. So there's nothing in common with these three terms. So those have greatest common factor 1, which means you could just move on like we did in the first two problems. However, this next problem has a greatest common factor that's bigger than 1. So we need to catch that. Let me go ahead and just kind of block this off too. Okay, so notice here I've got 3, 9, and 54. Well, 3, 9, so we don't want to jump straight to doing 3 times 54 and then going through it like we did the last problems. Again, we want to make sure we get that greatest common factor first. Well, out of these numbers, 3 does divide all of them, so 3 is part of it. And then I see x, x squared, and x cubed, so that means x is also part of it. Okay, so that greatest common factor I'd want to take out first. And, you know, sometimes I like to do this with the greatest common factor, just put it in its own parentheses. You could leave it without them. It's optional, but I like to do that. And then anyway, now let's adjust these three terms. So 3 divided by 3 is 1. X cubed, getting an x taken out of it, would be x squared. Minus 9 divided by 3 is 3. X squared, got an x taken out of it, so it's left with x. And then minus 54 divided by 3, that would be 18. And then x got taken out, so it's just minus 18. Okay, so with this problem, once the greatest common factor is taken out, it's just going to be there. It's done. So now our focus is just inside, let me just kind of bold the parentheses, is just inside these green parentheses. And you can pretty much just cover this 3x up. So, I mean, I can't do it electronically where I cover it up with my hand, but imagine it's really just not there. Just don't forget to rewrite it. Just keep rewriting it each step. So it's always going to be around, but it doesn't do anything else. It's already been factored out. We just want to keep it there. Okay, so really all it is factor this problem in the green, and then that means I can go to my method that I just did on the previous two. So I have a coefficient of 1 on this x squared, and then timesing it by negative 18 is negative 18. And so negative 18 has factors of 1 and 18, 2 and 9, and then 3 and 6. And so I look at all these pairs. I need to find the pair that adds up to negative 3. Well, I think if I did negative 6 and positive 3, that would do it. And then notice again that when these multiply, they do give us negative 18. Okay, so both requirements are met. And then now we can just continue with this. All right, so because the coefficient on our x squared is 1, so again, all I care about is what's inside these parentheses now. This 3x is just already taken care of. So the coefficient on the x squared is 1. That means I could rewrite this using these factors immediately as just x plus 3 and then x minus 6. And that's it. Okay, and then when we check it, I would say it's probably best to check the binomials first. So go ahead and multiply those first. So the 3x is just going to hang out again. Foil those first to check. So x times x is x squared. And then minus 6x plus 3x minus 18. These middle terms combine, so the 3x is still there. But I have x squared minus 3x minus 18. And then now I can distribute the 3x in. So the 3x distributes, I'd have 3x cubed minus 9x squared minus 54x. Yep, it's the same as what we started with. Okay, so sometimes the check can take a little longer than the actual factoring, but hey, it's always worth it to check your work. You got to make sure it's good. Okay, so let's see our number 6. So on number 6, we see, well, it's looking like there's x's in common in all of them. So let's take that out. So it looks like x squared needs to get taken out. All right, and then let me just go ahead and keep blocking. Okay, so x squared is the greatest common factor, so that's what I want to write out front. And then I'll set my parentheses up. So x to the 4 becomes x squared when we take the x squared out of it. Minus taking x squared out of that would give us 12x. Taking x squared out of that leaves us with plus 35. Okay, and then now again we're right back to where we were in the previous problem. So this x squared is just going to be there. And then I'm going to use my green parentheses again to just say, hey, this is our focus. I have a 1 times a positive 35, which is 35. And then the factors of 35 are 1 and 35. 2 doesn't go into it, 3 doesn't, 4 doesn't, 5 does. And then 7. And then that's it. 1 and 35 and 5 times 7. And then, well, one of these has to work. Well, it's got to be 5 and 7. And if we make them both negative, then it makes it the negative 12. And then again, notice that these multiply and give you positive 35. So both requirements again are met. Okay, and then because it's a coefficient of 1 in the front, let's just go straight to the answer, x minus 5, x minus 7. And that's it. Okay, and then again, I'm going to skip the check. It will work just fine, but to save a little time, let's move forward. All right, so that's, and if you need to take a pause, take a pause. Again, I'm going to finish all of the factoring off right now in this kind of longer video than normal. Okay, so let's see these other cases. Okay, so 4 more trinomials. All right, notice on this one, the greatest common factor is 1. There's nothing in common besides 1 with all 3 terms. This time around, though, the coefficient is not 1. It's a 2. All right, well, that really doesn't change the strategy. We're still going to take the 2, multiply it by the -3. We'll get -6. And then I want the factors of -6, so 1 and 6 and 2 and 3. They need to add up to give us -5. Okay, so be careful with these. Okay, so for instance, you might say, how about I do -2 and -3? Well, that does add up to -5. However, when you multiply these, it is not -6. Okay, so that means this is not the correct choice. So instead, it should be this one and this pair, the 1 and 6, and it looks like if I were to do a -6 and a +1, that would make it work. Okay, and then these multiply and do make -6. Okay, because the coefficient is not 1, we do have to just go back and rewrite our middle coefficient. So 2x squared plus x minus 6x minus 3. So I'm just rewriting the middle coefficient using these 2 new coefficients. And then now it's right back to grouping. So all it really does is just changes it back into the longer method where we've already done this before. So it's like our 1, 2, and 3. Okay, so we've done it. It was nicer when we had quicker ways for those easier problems. Okay, anyway, grouping these 2, I have an x in common, and then there's 2x plus 1 is left over. And remember, kind of check as you go. This does match. And then it looks like I should probably take out a -3, and I'd be left with a 2x plus 1. And again, check with the negative. It does change the signs. It matches. Okay, so it's good. Okay, and then now I do have my common binomial. The 2x plus 1 is common in both. So that means I could write it to the front. And then I'm left with x minus 3. So that x minus that 3 is in its own binomial right there. And there we go. Okay, so notice in our factors, 1 was around still, but -6 isn't. Okay, so that's again why you don't want to just rewrite it. So this time around, take the little bit of extra time and break it up and get it like this. Okay, and then again, you could check it. Let's go ahead and check super fast. 2x and x is 2x squared. 2x and -3 is -6x. 1 times x is positive x. 1 times -3 is -3. And then these add up to give us -5x. Yep, and everything else matches. Okay, so that's how we could break these down. Let's try this one. Okay, so, and again, you could always try any of these and pause and then fast forward. See if you're feeling good about it. All right, so our greatest common factor in this problem is 1. Nothing's in common between those 3 values there. And so then now I'm going to my method here where I take the 7 and multiply by 7. And I get 49. And then the factors of 49, well, there's only 2. 1 and 49 and 7 and 7. And so to get positive 50, it certainly looks like I need positive 1 and positive 49 to make that happen. Okay, and so then again, I'm going to just rewrite. I have 7x squared plus x plus 49x. So it is a 1. I decided you could put the 1 in there. How about we do that? I just wrote x initially, but 1x plus 49x is 50x. And then plus 7 still at the very end. Okay, and then again, we break it down, just group the first 2. So out of these first 2, it looks like x is in common. And we would be left with 7x plus 1. And then we have plus. Out of these 2, it looks like 7's in common. And we would have 7x plus 1. Okay, and then this time I'm just going to underline. Notice that this is in common in both terms. So let's take that out. So 7x plus 1. And we're left with x plus 7 in the second binomial. And that's it. Okay, and then if we were to check it, it would be good. I'm just going to move on, though, to save a little time. Okay, so that's what happens when you have something like these, when the coefficient is not 1. It's not that bad, all right? So it just takes a little extra time. Yes, these were nice because you had a shortcut, but these don't take much longer. Okay, so looking at 9 and 10, these are also trinomials. So still the same deal where I want to find the greatest common factor. Now this time around, it looks like 5 is the greatest common factor. So let's take that 5 out. And then we're left with, well, 10 divided by 5 is 2, so 2x squared. Minus 5 divided by 5 would be 1, so just minus x. And then minus 10. And then again, always check as you go, it's good. Okay, and then now it's just like it was in our previous, not our previous two, but the ones on the last page right here, where I'm focused only on this part, because the 5 has been factored out. That means it's good to go. It just make sure to continue rewriting it. And then all I want to do is write back to the same method I've been doing. 2 times negative 10 is negative 20. The factors of negative 20 are 1 and 20, 2 and 10, and 4 and 5. And then I'm looking to see, well, which ones of those make a negative 1? Well, I think a negative 5 and a positive 4 make that happen. And notice that when these multiply, I do get negative 20. Okay, so it is a direct match. All right, and then now I want to just rewrite the middle term. So I have 2x squared plus 4x minus 5x minus 10. And let me keep that in the green, just like that. Okay, and then again, this 5, so as we proceed, we just continue rewriting it, and then I want to work on factoring this. Okay, so these middle, or in the green parentheses, I want to group these first two and group the second two. So when I group the first two, and let's keep this green here for now. So for organization, I'm going to keep that green. So out of these two terms, it looks like 2x is in common, and I'd be left with x plus 2. And then in the second two terms, it looks like a negative 5 is in common, so minus 5. And it also looks like x plus 2. Okay, so in this next step, so it will look a little weird. Let's put the 5 still just there before we forget about it. But I kind of have a lot of parentheses that aren't going to be needed as much. Let me go ahead and underline this x plus 2 and this x plus 2 are in common inside the green parentheses. And let's go ahead and just keep the green actually for organization. So x plus 2 and x plus 2 is in common, so that means I could factor it out. And then I'm left with 2x minus 5 in my other binomial like that. Okay, so this is what it looks like. Well, at this point, we probably wouldn't keep the green parentheses. They're no longer needed. They were needed for these steps, though, up until now. So what we're going to do is just rewrite it. So I'm going to keep the 5, and the 5 in parentheses is optional. You could get rid of the parentheses on that as well. But the x plus 2 and the 2x minus 5, those individually must stay in the parentheses. Okay, so that is our answer. And again, the other way they might write this, sometimes they don't like to put the 5 in parentheses. So they might write it like this, and that's fine too. So these are the same. But again, these, the x plus 2 and the 2x minus 5, must be in parentheses. Okay, and if we were to check it, it would be good. I'm just going to say check it, especially on test. Okay, and especially if this is your not most comfortable thing in math, definitely check, because multiplying is easier than dividing. Okay, anyway, so one more trinomial, and then we'll be near the end here. So again, take a pause if you need to. All right, so in our next problem, let me go ahead and put a line there. All right, so I've got, it looks like there's something in common in all terms. So let's go ahead and make that note. Our greatest common factor out of these even values, well, I think, so 10 is the smallest value here, but 10 doesn't go into those two. The factors of 10, like 5 doesn't go into these two. I think it's only 2. I think 2 is the smallest number that goes into it. So we've got 2. And then we have our x squared, and x cubed. So that means let's attach an x with it. So we've got 2x is the greatest common factor that we're taking out. And we'd be left with a 5x squared minus 22x plus 8. Okay, and then again, no big deal. It's very much like this number 9 if you wanted to try it out. The 2x is just going to continue to be rewritten. And then I'm going to use my green again to say, hey, this is my focus. And all I want to do is, let me go ahead and get that space ready. All I want to do is take the 5 and times it by the 8. And we'll get 40. And then I want the factors of 40. And again, you could jump straight to it if you want to. I'm going to go ahead and write them all. Oops, let's write it in kind of order. So that's a 5 and 8. Okay, so there they all are in case we needed it. But again, if you know it right away, that's good. Like you could stop immediately at this one because this is where it is. I need a -2 and a -20 to give me -22. And notice when these multiply, it is positive 40. Okay, so now I'm just going to rewrite. So I've got 5x squared minus 2x minus 20x plus 8. So just rewriting those. And then now it's just grouping again. So these two and then these two. So the 2x is just going to hang out. And then I would have, out of those, let me get my green again. Out of these first two, I can take an x out. So we'd have 5x minus, 2. There we go. Sometimes the pen freaks out. Okay, so that's, and then double check, it distributes and matches. Okay, so x times 5x minus 2. And then out of these two, well, the -20, I think I probably want to take a negative out of that. I think a -4 is the biggest thing that's in common with these two. And then I'd be left with 5x minus 2. And again, our binomials are a match here that are now underlined in blue. So those two are the same, which means it can factor out. And so what I'm going to do, I'm just going to kind of skip one step and just say, I don't need those green parentheses anymore. I'm just going to write the 5x minus 2 and then the x minus 4 right after. There we go. And there it's all done. Okay, and that's how we could break it down. And then let's check this one real quick just to show, remember to, if you're going to check, FOIL those first. So we'd have 5x times x is 5x squared. And then 5x times -4 is -20x. And then we'd have a -2x. And then we'd have positive 8. And then the 2x that was factored out initially is still on the front. Don't forget that. But in here I can combine those middle terms. So we have minus 22x as the middle term now. And then when I distribute the 2x, it gives us the 10x cubed minus 44x squared plus 16x. Yep, and that's what we started with. Okay, so that means we factored it correctly. Okay, so anyway, so that's how we could break these down. Okay, so our last couple here is our last case. Okay, so we did a lot. All right, so again, you go pause it if needed. It's these ones. So all we're doing is check if it's ever two terms. Check to see if it's the difference of squares. Okay, so what that means is if this is a minus right here, you always just set it up and I just think, all right, what times itself is x squared? Well, x times itself is x squared. And then it's always minus plus or plus minus. So it's just that it doesn't matter how you write it, minus plus or plus minus. I'm going to do minus plus here. And then I'm looking at this term and I'm thinking, all right, what times itself is 81? Well, 9 is. And then that's it. Okay, so we're ending on the easier ones. Okay, and also, like I said, the order doesn't matter. You could have done x plus 9, x minus 9. That also works. Okay, so these are the same thing. And that's that. Okay, and again, very quick check. If I were to check it, I'd have x times x is x squared. I would have x times -9 is -9x. Positive 9 times x is positive 9x. Positive 9 times -9 is minus 81. These two zero each other out. And so we're left with just the x squared minus 81. Yep. Okay, so that's that. All right, let's do one other where we have x to the 10 minus 121. All right, so again, I'm going to just set it up where I know that it's going to be two binomials. I see the minus in between. And so I think, all right, what times itself is x to the 10? Well, you can kind of just say divide the power by 2. That's what we did here as well. If I divide 10 by 2, it is 5. And x to the 5th times x to the 5th would be x to the 10. And then I have minus plus, always. And then now I'm thinking, oh, what times itself is 121? Well, 11 times itself is 121. And there it is. Okay, and again, the plus minus order doesn't matter. You can write it just like that. Okay, and that's that. Okay, one side note to end on. Be careful if it's a plus in between. So like x squared plus 9. So don't say that this is x plus 3, x minus 3, because if you check it, it would not match the sign. And if you try any of the factors, you say, oh, how about I do this instead? Well, this wouldn't work either. This would have been x squared plus 6x plus 9. So you have a positive 6x that's missing here. Okay, so this does not factor. So if it's a plus in between, and these are still squared, this is not factorable. Something that's not factorable, we say is prime. Okay, so sometimes there's problems that don't factor, but most of the time they do. Okay, so if they don't factor, we would say it's prime. And again, so if it's a plus sign, so if that was plus there, it wouldn't factor. If that was plus there, it would not have factored. So only with the difference of squares. So difference means minus, and then these are squared stuff. Okay, anyway, so that's our factoring. So hopefully that gives you a nice refresher. In calculus, we factor a bunch, so it's very important. I really only covered one main method for these factoring. I think it's the most kind of procedural way to do it. Just it takes nice, easy steps to get there. There's other ways to factor though that I didn't cover, so I didn't want to throw too many options at you. I think that might be tough to absorb. But if you do need others, check out some of the other videos that are available that are not done by me, and they'll go over different factoring methods. Okay, so but whatever way you prefer is fine, as long as you are comfortable with it. So that's it. So thank you for watching. Take a break after this, and if you do have questions though, let me know, and I'll see you next time.